Welcome to AI Paper Podcasts. We cut through the noise and get straight to the core insights from the latest research. Today, we're tackling something pretty fascinating in the world of multi-agent LLMs. Are these groups actually coordinating? Or are they just kind of a bunch of individual agents guessing at the same time? We're diving into a really key paper here that introduces a novel information-theoretic way to actually measure if genuine emergent coordination is going on.
Yeah, and that measurement part is the real kicker, isn't it? We often see these systems perform well, and we say, oh, it's synergy, the whole greater than the sum of its parts idea. But proving it, showing that you have a real integrated collective forming, not just a loose collection of agents, that's tough. This research gives us a principled way to do it. Basically, it asks, can you predict what the group will do next only by looking at the agents working together jointly, and not just by looking at them one by one, the short-form 1-minute key insight summary.
All right, so if you just need the quick version for your next meeting, here's the 1-minute breakdown. The researchers develop a new framework using information theory, specifically partial information decomposition, or PID, and time-delayed mutual information, TDMI. They use this to actually measure real dynamic emergence in LLMs playing a collective guessing game.
And a key finding, you can actually steer this emergence. How? Well, the best results came from combining assigned personas for the agents with a theory of mind prompt. Basically telling GPT 4.1 agents not just, here's your role, but also think about what the other agents might guess. That really induced a stable kind of goal-directed synergy.
Right, and getting that good performance wasn't just about one thing. It required balancing two factors. You need redundancy, so agents being aligned on the shared goal. But you also absolutely need synergy, which means they make different complementary contributions based on those roles or identities.
And finally, a really important point, this kind of useful coordination. It really depends on the LLM's underlying capacity. When they tried this with a less powerful model, Llama 3.18b, it mostly failed to get that productive cross-agent synergy going. Instead, those agents just showed what the paper calls spurious temporal coupling. Basically, they got stuck in patterns, like oscillating, without actually achieving the goal.
Okay, let's unpack this a bit more. Multi-agent systems, they're everywhere now, and people make big claims about performance gains. But this paper asks a really fundamental question, doesn't it? When and how does real synergy pop up? And crucially, do today's LLMs even have the sort of internal reasoning capacity for it?
Exactly. It's about going beyond just looking at the final score, like the win rate, and digging into the informational structure underneath. Synergy in this specific information-theoretic way they define it isn't just things worked out well. It's very precise. It's information about where the system is going next that you can only get by looking at the agent's current states together, jointly. You wouldn't get that same predictive insight by looking at any agent individually.
Okay, that's a sharp definition. Can you give us maybe an analogy, like if we were looking at a sports team?
Sure. Think about a basketball team running a play. Synergy would mean that if you watch, say, 3 specific players moving right now, you know exactly where the ball's going to end up for the shot. But if you only watch one player, even the star player, or maybe the best 2 players together, you don't get that same certainty about the outcome. If one player is just so good their moves alone predict everything, that's dominance, maybe. But it's not synergy by this definition. It's about whether the joint interaction is necessary for that predictability.
Got it. So the framework uses partial information decomposition, PID, and time-delayed mutual information, TDMI. Okay, sounds a bit like alphabet soup. How do these actually help separate out, the shared info versus the truly unique group info?
Right. Well, PID is the tool designed specifically for this job, decomposing the information that multiple sources, in our case, the agents provide about some target variable. And TDMI brings in the time element. It asks, how does the state of the agents now predict the state of the group a little bit later? Putting them together lets you mathematically split the total predictive information into different pieces. Redundancy, which is info shared across agents. Unique info, which only one agent provides. And the really interesting one, synergy, the info that only emerges from the group interaction itself.
Okay, that's the theory. But practically, how did they apply this? The agents are just spitting out numbers, their guesses, right? You can't just feed raw guesses into this sophisticated model, surely.
No, you definitely can't. Raw guesses are messy. They mix up whether agents are aligned on the goal with how they're differentiating their strategies. It's hard to compare an agent guessing 5 with one guessing 500. So to get at the coordination itself, they did a crucial transformation. They didn't look at the raw guess. Text geogespo. Instead, they looked at the deviation from the equal share contribution. Text desdo.
The deviation from equal share, why is that the key signal?
Because it puts everyone on the same scale and reveals the coordination pattern. Think about it. If the target is 100 and you have 10 agents, the fair share guess is 10. If one agent guesses 15, that's a deviation of +5. If another guesses 5, that's mighty few 5. Suddenly you see who's overshooting, who's undershooting, who might be compensating for whom. That deviation signal reflects the coordination dynamics. The raw guess doesn't tell you that as clearly.
Okay. And the overall group signal they were trying to predict, the $, that was just the total group error, right? Sum of guesses minus the target.
Exactly. That's the macro level outcome they're trying to predict using the micro level deviation signals. And just a quick note for anyone thinking about implementing this measuring information, like entropy, especially with limited data, can be tricky. There are biases. So the researchers were really careful here. They used bias correction methods, and they also discretized the deviation data, basically binning it into just K2 bins using quantiles. Very robust approach to make sure the results weren't just noise.
Okay, measurement toolkit in place. Let's talk about the actual experiment they ran. They used something called the group binary search task. Sounds familiar.
Yeah, it's adapted from work on human groups, actually by Goldstone and others. It's a great test bed for coordination. They had groups of 10 agents, either GPT 4.1 or Llama 3.1 8B. They set the temperature parameter to 1, which encourages a bit more randomness and exploration of the guesses. Each agent proposes an integer, but they do it privately. The crucial part is that the sum of all 10 guesses has to hit a secret target number.
And the agents couldn't talk to each other. No peeking at others' guesses.
None at all. And the only feedback they got was at the group level.
Yeah.
Just your total sum was too high, your total sum was too low. That's it.
So that setup really forces some kind of implicit coordination, doesn't it?
Absolutely. Because if every agent just follows the same simple strategy, like a basic binary search where they all cut their guess in half if the sum is too high, they'll just oscillate forever. They'll overshoot, then undershoot, back and forth, and never land on the target. To succeed, they have to develop complementary strategies. Some need to anticipate the group undershooting and guess higher, while others maybe need to hold back a bit. It requires mutual adaptation.
Makes sense. And they found preliminarily that, like with humans, the task got harder with more agents.
Yep, replicated that finding. And also found that higher temperature, more randomness, actually increased the chances of success, interestingly. Maybe help break those oscillations. But the core of this part was testing 3 specific interventions to see if they could actively steer the coordination.
Oh, yeah. What were the interventions?
So first was the plain condition, just the basic instructions, focus on the binary search idea. That's the control group. Second was persona. Here, each agent got a detailed, distinct identity, like a name, a job data analyst, creative writer, personality traits, things like that. The idea was to give them a basis for specializing their roles.
And the third one, which turned out to be really important for GPT 4.1, was the theory of mind prompt, or TOM.
That's right. This took the persona condition and added a crucial instruction. They explicitly told the agents to carefully think through step by step what others might guess and how their actions might affect the group outcome. It's really pushing them beyond just having a role towards actively modeling and adapting to the rest of the group, trying to turn them from, individual reactors into truly integrated collaborators.
Okay, so they have these 3 conditions: plain, persona, TOM. Now, how do they measure the type of emergence happening in each? They use 3 specific information-theoretic measures.
Right. Let's start with the broadest one, the practical criterion. What's that telling us? Think of set-of-text macro as the first pass, a kind of coarse filter. It basically asks, how well does the group's error now predict its error later? And critically, does that self-predictability go beyond what you could explain just by summing up the individual agent dynamics? If text macros is positive, it suggests there's some kind of emergent dynamical synergy happening at the group level. It's sensitive to that multi-agent synergy, but it does get penalized if the system is overly redundant, if everyone's doing the same thing.
Okay, so it shows if something emergent might be there. Then they drilled down to the pairwise level with measure 2, emergence, capacity, text dependency.
Exactly. Text zooms in a bit. It specifically looks for dynamical synergy between pairs of agents. It measures how much information the current states of 2 agents give you about their future state beyond what you could predict from either agent alone. A positive score here confirms that, structurally, the system can support this kind of non-trivial synergy between components. It's about capacity.
Got it, capacity at the pair level. But the real test of functional coordination, the one that tells you if the group is working together effectively towards the goal, That's the coalition test using I3 and G3, right?
Okay. This is where it gets really interesting in terms of functional relevance. First, you have I3, which stands for total mutual information. I3 measures the total amount of predictive information a triplet of agents jointly provides about the future macro signal that future group error, VIT plus L. So a high I3 means the agents are kind of coherently organized and aligned towards predicting or controlling that shared outcome. Good
For
alignment.
the high I3 means alignment, but what about G3? That seems like the critical piece for synergy.
It is. G3 is the dynamic emergent synergy within that triplet. It performs what they call the coalition test. It specifically measures the extra predictive information you get from the whole triplet over and above what you could get from just the most informative pair within that triplet. So it's asking, do we really need all three agents working together to predict the outcome? Or could the best two agents have done just as well on their own? If G3 is positive, it means the group's predictability relies on structures or interactions that go beyond simple pairs. It localizes genuine multi-agent synergy.
That's a really stringent test. It filters out cases where maybe just two agents are coordinating well and the third is tagging along. And they also ran some checks to make sure these measures weren't picking up on spurious effects, like shuffling things around.
Yeah, absolutely crucial for robustness. They use two main types of surrogate tests. Row-wise shuffles involved scrambling which agent was which across different time steps. This checks if the synergy is truly locked to the specific identities or roles. And column-wise, time shift surrogates involved shifting the time series of different agents relative to each other. This tests if the observed coordination is genuinely about simultaneous dynamic alignment, rather than just some lagged correlation by chance. These tests help confirm the signals are real structural features, not artifacts.
Okay, so let's get to the results for the powerhouse model, GPT 4.1. Did it actually show this capacity for emergence when put through these tests?
Oh yeah, definitively.
Yeah.
The practical criterion and the emergence capacity both came back highly significant across all conditions, plane, persona, and Tom.
So the basic structural capacity for dynamic emergence, it's clearly there in GPT 4.1.
The capacity exists, but the key question was whether the prompts could steer the quality of that emergence. Did the persona and Tom prompts actually make the agents behave differently, like specialize? They absolutely did. When they analyzed the agent's actual contributions, how much each one guessed relative to others, and how they adjusted their guesses over time, their learning rates, they found significantly more differentiation between agents in the persona, and especially the Tom conditions, compared to the plain one. And interestingly, you could even see it in the agent's chain of thought reasoning. They'd explicitly mention their assigned persona, like, as a data analyst, I should probably adjust downward. So yes, differentiation was successfully induced.
Okay, so the agents took on different roles. How did that play out in terms of actual coordination, the alignment, and synergy?
This is where the conditions really diverged. The plain condition, it showed strong temporal coupling, meaning agents' actions were predictable over time, but it lacked strong cross-agent alignment. It was like they were stuck in their own loops, not really coordinating effectively with each other towards the goal. The Tom condition, though, was dramatically different. It showed significantly higher total mutual information, I3. That means much stronger alignment, much more coherent organization focused on predicting and influencing that group error signal. Essentially, the Tom prompt managed to get the agents to be both differentiated and integrated simultaneously.
That sounds like the magic combination for good performance, right? Did this balance of synergy and redundancy actually lead to more wins in the guessing game?
It did, but it was the interaction that mattered most. This is a really key finding. If you just looked at synergy alone or redundancy alone, neither strongly predicted whether a group would succeed. But when you looked at groups that had both high synergy and high redundancy, their performance shot up significantly. They quantified this interaction effect, finding that redundancy boosted the positive impact of synergy by about 27% and vice versa. Wow. Okay, so it really is a case of needing both alignment on the goal, redundancy, and different players contributing unique skills, synergy, to make it work. Classic collective intelligence idea, basically. And the Tom prompt was the causal driver for this. The analysis suggests so. They did a causal mediation analysis, and it pointed towards the Tom treatment increasing the win rate indirectly. How? By boosting that functional synergy, the G3 measure, it suggests the Tom instruction wasn't just fluff. It fundamentally rewired the coordination dynamics within the group, enabling them to leverage those specialized roles effectively to solve the problem.
Which brings us neatly to the other side of the coin, the capacity gap. This is a real cautionary tale in the paper, isn't it? What happened when they reran everything using Llama 3.18b, a less capable model?
Yeah, it's stark. The Llama groups basically couldn't do the task. Their overall success rate was only about 10%, just dismal performance compared to GPT 4.1. And here's the kicker. The Tom condition, the very thing that made GPT 4.1 succeed. It actually made the Llama 3.1 groups perform significantly worse than the Llama groups in the simple plain condition.
Worse. How could telling them to think about others make them perform worse?
It seems like trying to force that complex coordination strategy onto a model that didn't have the underlying reasoning chops for it was actually detrimental. It might have just confused them or locked them into even more rigid, unhelpful patterns.
So did the information measures just show zero emergence for Llama then?
No, and this is where it gets subtle and quite interesting. The Llama groups did show signs of structure. Their I3 scores, the measure of total predictive information and alignment, were actually pretty high. They showed predictable organization over time. But their G3 scores, the measure of true, functional, cross-agent synergy, were significantly lower than GPT 4.1's, and often not statistically significant. This is what the researchers termed spurious temporal coupling.
Spurious temporal coupling. Can you break that down? What does that look like?
It means the ages are definitely reacting to each other. Their behavior is tightly linked over time, creating predictable patterns, maybe oscillations, maybe some other repeating cycle. So I3 is high because there's a pattern. But crucially, that pattern isn't functional. It's not actually helping them solve the task or converge on the target. They're coupled, yes, but in a way that's maybe chaotic or just stuck, not productively adaptive. They have the appearance of coordinated structure, but lack the goal-directed function.
Ah, I see. So they're like locked in a dance, but the dance isn't actually getting them anywhere useful. They couldn't execute the sophisticated theory of mind reasoning needed to develop those truly complementary roles and break out of the unproductive cycles.
That's exactly the interpretation. It really highlights that achieving functional synergy isn't just about giving the right instructions or prompts. The underlying model, the LLM itself, has to possess the necessary reasoning capacity, maybe something akin to what the Tom prompt requires to actually implement that complex, adaptive, mutual modeling. Capacity seems to be the real bottleneck here. Hashtag tag tag outtray.
So wrapping this up, what this research gives us is, well, a pretty robust framework and compelling evidence connecting ideas from collective intelligence to these multi-agent LLM systems. We've seen it's possible to actually steer a group of LLMs from just being a loose collection towards being a more integrated, synergistic collective. But, and it's a big but, this hinges entirely on the base model having the chops, the reasoning capacity to handle both that differentiation of roles and the integration needed to work together.
Yeah, and what's really striking is how these informational signatures,
Yeah.
the need for both redundancy, alignment, and synergy specialization, echo decades of research on what makes human teams effective. It's a fascinating parallel. Of course, we need to be cautious, right? Finding evidence of synergy as an information-theoretic property, a structural feature, doesn't mean these LLMs have consciousness or deep understanding like humans. It points to a capacity for complex, goal-directed computation and interaction.
Absolutely. And that leads perfectly into our final provocative thought for you, our listeners, to chew on. Given those Llama 3.1 results showing that you can get this spurious temporal coupling, which looks structured and predictable, high I3, that isn't actually functional, low G3, it raises a really practical challenge for anyone building these systems. How do you go beyond just looking at win rates or basic task success? How can you use frameworks like this one to actually validate that your multi-agent system is exhibiting productive synergy that helps achieve the goal, and not just complex, maybe even chaotic interaction patterns that ultimately don't lead anywhere useful? Something to think about.